Hello, my name is Deepthi Krishna. I am a data analysis intern at Static Academy. In this video, I will be explaining my task that I performed in deep learning. Coming to the problem statement, here we create a deep learning model that can detect if arthritis is present or not in a given knee X-ray image. So coming to the introduction, as I am working in deep learning, I understand that deep learning has proven to be a powerful tool for pattern recognition that handles huge amounts of data. And here the most extraordinary thing about deep learning is that it uses the use of hidden layers, which generally is meant for feature extraction when compared to the traditional techniques. And one of the most popular deep neural networks is that convolution neural networks. So firstly, what I'm trying to do here is I'm trying to access my Google Drive files in this Google Colab. So I am using this snippet in order to mount the files onto this Google Colab. So next, I am trying to import the libraries which are necessary for my data analysis. Sorry for the delay. I am running my day, implementing it. So we can see that my data is mounted at this okay, at this particular path, and I have imported the libraries that are useful for me, which are useful for both numerical calculation as well as the visualization part. And after that, I am loading the other dependencies. Here, as I told you that I will be using convolution neural networks. In this convolution neural networks, it is understood that I have a input layer followed by a number of hidden layers, and which is followed by the output layer. So here it depends on how many hidden layers that you require, but I am using a sequential model which is mainly appropriate for plain stack of layers, which means that we have exactly one input tensor and one output tensor in each layer. So when there is a convoluted image which is too large, it can be reduced without losing features. So this can be done using pooling, which is nothing but here we will be doing max pooling. Okay, and here creating a neural network is to initialize the network using the sequential model. So here I can explain. So, as I told you, I am using a sequential model, and here in this input layer, this all includes the input layer. In this input layer, we are using max pooling in order to reduce or avoid losing features. Okay, next, and here we are using now, if you can see, our convolution layers would be including 16 3 by 3. So here ReLU is nothing but it is one of the activation functions. The possible functions here we know that are ReLU, sigmoid function, hypertangent, and also sigmoid function, softmax activation function. Out of this, we know that mainly we will be using ReLU, which is most popular for deep learning, and softmax function in the output layer. So this is about max pooling, and here flattening is mainly used for transforming or converting the two-dimensional matrix into a vector of features. Similarly, we will be using the dense feature here. If you can see the dense feature which is included in the hidden layer, which is used for feature extraction, this is a fully connected model and it is known as the hidden layer. Here we will be using the dropouts. What is the use of dropouts? Is nothing but to avoid overfitting. Okay, you can also have this dense in the output layer. Here we have dense in the hidden layer as well as dense in the output layer. Here in this output layer, it contains only one neuron. There is nothing but which gives you the probability. Like based on the probability, you can decide on which to which category the particular sample belongs to. Or here, when we are talking about image, we will be deciding which category the particular image belongs to. This is about it, and we display the summary of the convolution neural network model. Here if you can see, there is a shape for it. You give an input shape here of 180 by 3. Here you get this, and these are the parameters included, like here this is known as, I told you, this is the input layer. So at each level, how many are considered? So what is the type of the layer that you are considering? What is the output, or what is the shape of the output, and how many parameters are considered? Similarly, this is the thing, and if you can see, this is the total number of parameters. All the entire parameters have been trained, and nothing have been left untrained. This is what it means, non-trainable parameters. Now, next, we set up the data directory and generate the image data. So here we will be setting the training directory. Now we know that we have three folders. Okay, three folders which will be consisting of these images of normal as well as the arthritis images. So the three folders would be the training the training directory, the validation directory, and the test directory. We will be mentioning the paths, and BS is nothing but the batch size here. Here I am setting it up to 30, and here I am using this TensorFlow. So if you can see, this image data generator is mainly used for rescaling purpose. I have mentioned everything in comments. So we will be setting up setting up all this data generation. Okay, data directories. I told you about data directories, and here we try to generate the image directories. If you can see, we are giving the batch size, what is the class mode, which is categorical or binary, or what is the target size of the validation generator, the test data generator, and the train data generator. This is how it okay. So we found that 2350 images means, like the first one, the trained data generation images, belongs to the two classes. When it comes to the validation, the 641 belongs to two classes, and this belongs to 845. Now, next we come to the specification of the optimizers. Generally, we know that optimizers are used to reduce the cost calculated by cross entropy, and these are generally used to reduce or to these are used to calculate the error. And here we have three components, like when you compile the model, it has three parameters like optimizer, loss, metrics. Okay, here optimizers can be atom, or you can use the other metrics too. Here I have tried with a different one, but then my what you call uh, the probability and was very less, so I had to change. Even the loss, I tried with binary cross entropy as well as the categorical. I had good results with categorical cross entropy, and here the metrics, as I told you, it is accuracy. Okay, coming to this one, here I am trying to fit the model. Okay, here I am mentioning how many epochs, how many steps per epoch, so how many epochs should I consider, and how many steps in the validation, and this is how it is represented. I think it's still running. Okay. Hmm. I have actually worked on with epochs like 20, 30, and now I have already done with 50. If you can see, there are two metrics here, which is nothing but accuracy and val accuracy, which are nothing but accuracy of this. ACC is nothing but the metric which is used to calculate the accuracy of prediction obtained in the training set. And here this would be from the test set. So if you can see, there is a change 66 and 60. So my model is working in this way. So next, after I train my model, I'm saving my model so that I can use it for later purpose. Okay, so this is the path of this saved model. And after I have saved, I'm loading it to this Keras, so that like I can test my data. So for example, if you can see, I am just reading an image. Okay, and this belongs to the test generator file, and this is how I have mentioned, as I told you, the same thing. What I'm mentioning, the batch size, the class mode, the target, and I found that in the test data generator I have 845 images which belongs to the two classes, and I'm trying to predict. And firstly I have tried to generate how many files are there. This 845 files are there, right? So I just wanted to generate, and I tried to display the classes of it. So for the first image, so there is a possibility, like when the possibility is for arthritis. Similarly, second one is also belonging to arthritis. So this is how it displaying. So I'm trying to predict. So after this, as you can see, I've just considered two. So the possibility here for the first item is arthritis. I told you here, right? The probability is higher for this second class, so which is nothing but arthritis. Okay. So this is how my model is predicting. These are the image names. You can, so let us compare the actual and predicted. I try to okay, try to write a function for this. This is the actual function and this is the predicted function. So I try to create a data frame for this image name actual and predicted. I just wanted to do to know how well my model is working. So if prediction summary, like actual of I is equal to prediction or predicted of I, so how many corrected is like 276. I tried to visualize it using the confusion matrix. This is how I've got. So I think my the accuracy, the performance of my model is low, and I've also tried with the different uh, now like so here we can also enhance this model by changing different parameters changing changing different number of parameters, and also the number of epochs. Like epochs is nothing but you try to try to read more data, no? Like more number of times, so that it helps you to predict well. So this is what it is. I was trying with different different parameters, like using different loss functions here instead of binary. I try to use categorical. So I tried with different things. So this was what I got. Actually, I also done little similar using transfer learning too. I will just show this. Um, Transfer learning, but then my results were not so appreciable, so I didn't want to load this. So I am fixing with that. The same thing is happening with this transfer learning too, where I was using this um, BGG16 but then there was no change. And I also tried to use a sequential model with different number of layers. Like for example, here I have used 16 3 by 3, right? So I also use 32 32 64 in the input layer, and then in the hidden layer I use some other metrics, and then in the output layer I used only two dense of two, uh, but it didn't really help me. And this is what this was better than the previous sequential model which I used. So I have fixed with this. So this is what I have done. Thank you.